Good morning. My name is Andy Kerr. I lead a big public-private innovation partnership called Climate-KIC here in the UK. And I'm going to speak to you about three topics this morning. The first is the sources of greenhouse gas emissions in Scotland and how they've changed through time. The second is the greenhouse gas emission totals and how that has changed through time. And third, I'll talk a little bit about what we call negative emission technologies, which we'll be hearing more and more about in the coming years. Let me start to talk about greenhouse gas emission sources and the total greenhouse gases that we've got in Scotland. It's worth noting that the figures that I'm going to use are standard official statistics. There's no real debate about these figures. They're provided using fairly standard international approaches and methods, but they do take a long time to be produced. And so what we're seeing is figures from 2 years ago. So the figures I'll be using are from 2018. We won't get the 2019 numbers until partway through 2021. So in Scotland, we've got 5 main emitting sectors. The biggest sector by some way is transport, and that's petrol and diesel cars, vans, trucks, heavy goods vehicles, buses, and so on. And that emits about 12.9 million tonnes of carbon dioxide equivalent each year. And that's reduced by about 5% over the last 30 years or so. The second one is on business and industry, and that's energy use in business. And that is about 8.4 million tonnes of carbon dioxide. It's went down about 30%, 32% over the last 30 years. A big chunk of that was in the first decade when we were shutting major iron and steel work like Ravenscraig and reshaping around a service economy. But more recently, the emission reductions have been driven by efficiencies within the industries. The third is agriculture, and that's got about 7.5 million tonnes of carbon dioxide equivalent. And that comes from largely dairy and beef cattle and from sheep farming, and also from nitrous oxide emissions that arise when we disturb the soil when we're farming crops. The fourth sector is the energy sector, so that's power generation largely, about 6.8 million tonnes. Now, this used to be by far the biggest sector when we were using a lot of coal and gas for our power sector. But now in Scotland, we're predominantly powered by renewables with some nuclear, and we only have a couple of a much smaller plant which are used as gas, used as backup, so gas plant, sometimes diesel plant, and that's at about 6.8 million tonnes of carbon dioxide equivalent. And then finally, we've got the residential sector, which is at about just over 6 million tonnes of carbon dioxide equivalent, and that's largely gas for heating and cooking, but mostly for heating, plus some solid fuels for heating as well. Now, in addition to those, we've got a number of very much smaller sectors. We've got industrial processes. So, for example, if you make cement, by the chemical reaction of making cement, you generate carbon dioxide. There's also waste management. So if you create methane, if you leave organic matter in, say, landfill sites. And there's also the public sector and so on. But those are much, much smaller. But I also want to talk about these things called negative emission technologies. And negative emission technologies are a suite of human-made technologies which are driven by absorption technologies, by membrane technologies, by chemical means, which actually essentially suck carbon dioxide out of the air. Now, in one sense, this sounds like a silver bullet. You know, we can just carry on as we were per normal, and that will just sort all our problems out. But the problem with that is that there are real challenges in how you can scale up these types of technologies, because A, they are very, very expensive at the moment, and B, they're also very energy intensive. They take a lot of energy to actually absorb the CO2 out of the air. So, and the other thing is that we've talked a lot about some of the co-benefits that come from decarbonising, cleaner air in our cities and towns, warm, affordable homes if we're going to retrofit all our homes to improve their standards. These types of co-benefits won't be seen if we simply leave everything as it is and simply try and suck stuff out of the air as well. So what we treat negative emission technologies and the way we think we're going to be using them is very much as a last resort to suck up the emissions from sources where we are really struggling, the really hard to get sources like some of the agricultural emissions, like some of the industrial process emissions or from heavy industry, which are really hard to decarbonize. But otherwise, we would try and decarbonize other things first, like and do that largely by generating more renewable electricity and electrifying things.